それでは午後の部を始めてまいります。はじめにトマス・スタンチャクさんお願いいたします。We will now begin the afternoon session. To start, please welcome our first speaker, Mr. Tomasz Stańczak. The floor is yours.
Hi everyone, great to see everyone. And today we'll talk about $1 trillion security program and describe a bit the future of the Ethereum security for the Ethereum Foundation programs. My name is Tomasz Stańczak. I'm co-executive director at Ethereum Foundation since March, April this year. And let's review. The initiative for the $1 trillion security is something that we announced, I think, late April this year. And for the blog post announcement, we said that when we think about the future of Ethereum, first of all, we think that already nowadays, Ethereum is the very robust platform among the blockchain networks, considered to be like zero downtime, very secure platform with lots of tooling that evolved over 10 years into tools that have some standards, have some standardized approaches to smart contract security. But it's not enough. We want to go much further because we expect massive growth of the on-chain activity, massive growth of the number of assets that will be tokenized and deployed on chain. So whether it'll be stable coins, it'll be equities on new tokens, or whatever it is, we think that if we want to talk about billions of users and we want to allow them to safely store assets on chain, then let's average this on the $1,000 per user on average, and that gives you $1 trillion security. But you also want to think about the largest of the institutions on Earth to feel very safe about using Ethereum for whatever they're working on. So if they will deploy smart contracts for the large tokenized funds, then maybe they would hit the $1 trillion in a single fund. So how to think about the new level of threats when the honeypot is so large, the $1 trillion to grab for any attackers, including state actors, any organized crime, or maybe even other chains or competitors thinking that they want to showcase any vulnerabilities that can be detected. So all of those are very heavy threats, and they target potentially any aspects of the Ethereum stack, and we want to approach it in a very organized way, reach out to community, ask questions, and start addressing the problems that will start appearing as the money goes up. So the 3 stages: mapping of all the security issues, surveying the ecosystem, asking questions about what really the problems are. Does Ethereum Foundation and ecosystem, is everyone aware of what security threats exist, what security threats caused the attacks and money lost in the past? And splitting that into 6 areas. In the announcement, we mentioned UX, wallet security, smart contract security, infrastructure, protocol consensus, and the protocol security as the client and design of the protocol. Then the second stage is executing all the changes suggested or selected changes, providing grants, supporting the teams that build dashboards, that build solutions, that improve Ethereum security, and also communicating, educating and communicating about the changes, about the security issues, about the new tooling, educating developers, educating users, bringing awareness of the security risks of the new paradigm for many of the users that come to blockchain from the traditional finance world. Yeah. All right, and then we also published, after the first survey of all the threats, we published a report that splits all the information into actually six categories. So we adjusted it to user experience, smart contract security, infrastructure and cloud, consensus, but then also we pointed out a monitoring, incident response, and mitigation as very important aspects of this. In a decentralized network, how do you communicate with everyone that something bad is happening? You require non-centralized coordination and exchange of information between participants that also should not really trust each other to too much of an extent. So you cannot have a single coordinator that everyone will trust because maybe this is an attacker. And the social layer governance, so whether it's DAOs or the social consensus aspects, the reaction of the community when the technology fails, and you have to resolve issues either through the social consensus or DAO changes and deployments. So some of the things that happen very naturally, and I think they would happen also without this initiative. So nowadays we announced 2 million back bounty for the security of the Fusaka upgrade. So there is the Fusaka audit contest for up to $250,000 per bounty for the security researchers, auditors, back bounty hunters. That's available, and Fusaka is targeting release on testnets now and very soon, and the mainnet Fusaka probably around the end of November, just after DevConnect in Argentina. So very important release for us, and very big aspect of Ethereum security is continue this 10 years of downtime, no downtime into 20 years of no downtime and forever of no downtime. I think it's all about this no downtime culture that it gets really inscribed into Ethereum. So in the report, we mentioned the UX challenges, some of them more obvious, some of them less obvious. So the key management, over many years, because key management has been always mentioned as a one important aspect of Ethereum security concerns. So the key management tooling did improve significantly for enterprise users, for the custodians, for the hardware key management solutions, and so on. But still, we want to see how it's solved in all the more advanced scenarios. So when you think about enterprises and they have to do the key rotation when the employees leave the company and you want to replace the keys in multi-sigs, when you have to manage them in the corporation in general, some of those edge cases or the change management processes are still not standardized. Blind signing, transaction uncertainty. So we know from many cases when we participate in multi-sig signed transactions, very often we see hashes, no detailed information about transactions we are signing. So that's what we call blind signing. You sign something, but you're not certain that's what's really happening. So you would like simulations, you would like the good description of the transactions that you're signing, and so on. Approvals and permissions management, somewhat related. We're using applications. We set approvals for spending from our account. We do delegations now also with the account abstraction solutions. How do we manage standardized way all these approvals, permissions, revocations, authorizations? The web interfaces, UX, can be compromised. We see problems with DNS, with cloud infrastructure under attack, and so on. Privacy itself delivers security challenges. So the security of the users, the more information that leaks about the user activity, the more sophisticated attacks can be executed by the attackers. And all the problems of the fragmentations of the UX, of inconsistent usage across the various L2 stacks, bridges, wallets, and so on. So there's fragmentation of approaches, and the standardization should help with this. Smart contract security. So continuously we see the risks related to contract upgrades, famously the reentrancy problems that we're addressing now with the pay opcode most likely in Amsterdam. Any references to external libraries, unaudited components, so not everything is verified on chain. It's not automatic verification whether you're interacting with audited contracts. The audits themselves, probably auditors require auditors of how we create the dashboards and some kind of auditing of the quality of the audits executed on different protocols. Access control failures, unauthorized access. So all of the standardization of how you really control within the organization who can use particular smart contracts for managing vaults or larger amounts of money. Bridges and cross-chain, part of the fragmentation questions. The EOA delegation within the account abstraction, so all the standard accounts, how they get delegated to execution for the smart contracts, and also a novelty. What we really do if people start getting used to generating code with AI for the smart contract security, for the smart contracts, how you can make sure that you not only generate code with AI, but also verify code with AI, and the verification standards and the training for the LLMs that are used for security are of high quality. The other aspect of the smart contract security is also developer experience. How easy it is for developers to ensure that the smart contracts that they're deploying are safe and that they have all the tooling needed for that. So I keep thinking what secular means here. Lack of defaults in popular frameworks, so security defaults. The custom code for advanced operation controls. Once again, like some pre-deployed smart contracts that can be reused by smart contract developers to not recreate these advanced code concepts in each organization, because we have some standards for maybe more standards tokens, but the more and more advanced features are not yet fully standardized. Inconsistent testing coverage reports. The formal verification methods getting more and more adoption, particularly in the ZKVM's world. There is a big program from Ethereum Foundation with $20 million funding for verification of ZKVMs, and we would expect the propagation of the formal verification tools and methods for the smart contracts will be gaining some traction. The issues related to contract verification, compiler risks as well. In the past, there were some issues with compilers that led to the loss of money. Entire Ethereum community really relies on SOC as a compiler. So any risks that there would be a major issue in a compiler would cause major trouble in the ecosystem. So now the question is, with the compilers, actually compiler diversity, it's a different problem, right? Like, because you're deploying something and you're not doing the compilation with all the different compilers. Each one will have a different output anyway. So you don't have the same concept of gaining from diversity, but it introduces at least some concepts of competition to the compilers and forces people to make better optimization. Maybe it leads even to more security risks. Programming language diversity and depth, so more tooling for the smart contract developers to feel that the programming language, like Solidity or any alternatives, provides them tools for writing more secure code. Also for the on-chain code that is already deployed, many of the organizations that deploy on-chain code are not used to the standards. With their standards, process, and requirements, they don't really map into the smart contracts world. So that's why it's so important for the Ethereum Foundation and ecosystem players to introduce standards, new standards for smart contracts, or really adapt the existing standards to smart contracts, because many of those existing cannot be used straight into the code that is having all those assumptions of immutability, like everything that's related to blockchain release. For the infrastructure and cloud security, what we've identified, so obviously for the L2s, you start to think about asset complexity. What with assets that are breached multiple times, that are hopping, how do you really combine the security of the L2s, the exits, with assets that are wrapped multiple times? How we verify the security of the proving systems for the L2s. So this is very often like the formal verification, all the bounties related to ZKVM's comparisons, the solutions like 2 out of 3 or 2 out of many for the ZKVM. For DevConnect this year, we're preparing this major goal for the, I think, 6 major ZKVMs to publish real-time proving. And one aspect is the latency performance nowadays. The other aspect will be security and formal verification. So in line with that chase for who publishes the real-time proving, we also chase them to do the full formal verification. The thing is, these code bases are still evolving, and formal verification is particularly expensive, time-consuming format for the code that is more set in stone. So we'll always have to have trade-offs of what can we formally verify. Security councils themselves are always at risk of being multi-sigs, and the key holders of the security councils can be under attack. So this is big risks for the major L2s. RPCs and node infrastructure, this is aspect of many of the RPCs that are being maintained. If they would go down, then suddenly users are not able to connect to Ethereum network. And that might be The case in the past, maybe you remember there was an issue with the GAF upgrade on the Infura network that really disabled access for many of the users to the Ethereum network. And the case here is we want to improve RPC's network through the dashboards, comparison, security tooling, but also provide privacy for users interacting with RPCs. This is a bit of a separate track, maybe related to security, but more to privacy. DNS level vulnerabilities, so all the UX that people use for using smart contracts can be hijacked by replacing the website that is being accessed. So DNS hijacking, domain seizures by the governments, and all the type of phishing by deploying lookalike domains. Software supply chain and libraries, you probably heard recently, a few weeks, 1 week ago, 2 weeks ago, we had this software supply chain at risk. So some of the major popular libraries and the NPM packages had malicious package injection. So many of the tools in the Ethereum ecosystem, broader blockchain ecosystem, were at risk. So questions are, if that happens, how do we communicate, how we monitor those situations, how we prevent them by maybe storing the globally used packages in a particular signed way, so all the tools in the blockchain can refer and check which versions have been used for a longer time. Front-end delivery by itself, like so any malicious injections through the cloud-hosted platforms or content delivery networks, posing risks as well. The internet service providers on this level, we're asking really about censorship and, well, any spying of activities. So you can see risks to users mostly on throttling access, filtering requests, geofencing or IP bans, and deep packet inspection, all of this just to prevent access to Ethereum network, right? So here we're talking more about the Ethereum network access and security of being able to access the network. On the consensus protocol side, so risks related to the consensus itself, so how we continue research towards a very robust protocol that can handle all the different edge cases. There was a post from Vitalik a few months ago, I think, about how we should really create the teams at the Ethereum Foundation and broader in the ecosystem that will be trying to verify the edge case scenarios of the large attacks and recovery. So if we create attacks on the consensus, how quickly the network will recover? Will all the validators be able to come back to operation? We had in March, I believe, an issue with Holeshki network, where when Holeshki network failed, the validators had real trouble to recover. The case for Holeshki maybe is less severe, should be much less severe than for mainnet, in the sense that less people were paying attention and trying to make an effort to recover Holeshki than they would in mainnet. But at the same time, it also raises a lot of concerns and questions. If people don't have this fire drill of bringing back Holeshki and other testnets, devnets, then how they would act in the case when the mainnet happens, when it's also more stressful and rushed and there is a massive amount of value at risk. Client diversity, typical discussion about the safety of the Ethereum protocol through the execution client and consensus client diversity. It generally improves the robustness of the network, but also incurs a lot of costs on development and coordination efforts. And also famously, as we are chased for fast deliveries, the client diversity on one side improves security, on the other side sometimes is being claimed to be the reason for delays in deliveries. Very likely, good security approach and testing from all the clients together accelerates deliveries, but it's hard to create that impression. Any risk to staking centralization, pool dominance, undefined procedures for social slashing. Once again, we want to have various large-scale testing frameworks for this type of events. So we start talking about really huge multi-billion-dollar attacks that are coordinated and executed with the network as a target. And all the risks to quantum computing, long-term roadmap, very clear roadmap for what we would like to do on quantum side. And much of this is coming in the Lean Ethereum project that was initiated by Justin Drake, and it's now coordinated by Ethereum Foundation. Also, the economic gain theoretic attack vectors, so everything related to MEV, griefing attacks, economic activity. If you remember, I think 3 years ago, there was the attack on the MEV setup with 3 layers and builders, which after execution stole $25 million from MEV bots. Nowadays, we have, I think there is a trial ongoing on the case, and the vulnerability in the infrastructure was fixed. But we see that as we combining infrastructure, the protocol with the off-chain execution or the off-chain components, those vulnerabilities can get into the broader ecosystem, and we should keep looking at how to avoid them. Once again, in monitoring incident response, how do we reach affected teams? How do we escalate problems? So if we detect that some of the major networks continuously ignore some security issues, what are the escalation paths? Generally how we coordinate the response. In cases, one thing is the reaching out to the teams, but if there are more teams and it requires all of the teams to execute some actions in a synchronized way, how do we execute that coordination in a decentralized way? Generally, what kind of dashboards we have nowadays for monitoring all the security. Sometimes they are there, but it's like it requires knowledge of where to find them, and just coordination of finding all of those dashboards, security dashboards, is something that Foundation can help with. And finally, also how all the different affected teams, what kind of access to insurance they have. So combining the financial markets insurance with the risks of protocol. Social layer governance, well, the risk of stake centralization that may lead to various misbehaviors like malicious actions from the operators. So here you have a link to the pretty recent event, I think a few days ago, or maybe even more recent, where the Monero network that is having a majority staker operator, Cubic, goes into the 18-block reorg because of selfish mining. Well, not staker, the miner. And can it be also executed as part of the government actions, regulatory attacks, and the other aspect is what can happen with the organization capture of the governance processes. So if you have all core devs and all core devs suddenly stops being decentralized and gets into under the control of a single organization, what would happen? How we avoid this situation? I think that in the Ethereum space, this particular case is very, very far from possibility, but we should be always aware of like what is the sequence of actions and governance changes that would lead to that situation. And well, why do we do all of this? Why we identify those risks? Why we talk about them openly? Is because we want to maintain the zero downtime culture. We want people to be obsessed and scared that this a single moment of failure would erase 10 years of zero downtime. So we want developers to, when they join whether it's Ethereum Foundation or client teams, to think that this is a single worst thing that could happen, that any major security events happening on Ethereum network are losing a lot of this, the culture and legacy of building for 10 years with appreciation for testing, verifying, checking everything. And all of this while we want to maintain a fast delivery processes, robust and predictable delivery processes with never missing timelines and deadlines. That means it requires a really fantastic process. I like to talk about it that whenever I travel with trains in Japan, I expect them to come exactly on the right second, and somehow I feel also safer, because I think that this is part of the quality process, that not only you arrive on time, but also that everything, all the inspection processes are perfect. So what we bring as part of the support, so we look at the wallets and the UX space. So there's one of the 3 things that I'll repeat once again at the end that we're addressing in the first wave of the actions. So WalletBit is now the dashboard that is comparing the security aspects and privacy aspects of all the wallet providers. So this will grow over time. We want to continue building dashboards, supporting dashboards. They are all independent, like L2Bit, WalletBit, and so on. L2bit itself looks at the risks and security risks and asset risks on different L2s. So if we have dashboards like this, we can also continue with the RPCs, with infrastructure components, with the clients comparisons, and so on. Then we start to collaborate with the OWASP that is used as a framework for the cybersecurity in the Web 2, and we build the same setup for the smart contract security. What were different suggestions that we received within the survey? All the people from the ecosystem were sending ideas, and here is a very quick review of various ideas that we've received and we're looking at and thinking of how to address this. So all the standards for transaction simulations to avoid blind signing, the verification of push notification signatures, and maybe trust labels from different repos that can be delivered to wallets, so standardization of those. More ENS adoption, some kind of pause and verification for larger transfers or wallet draining mechanisms. Passkeys adoption. Here, SECP 256R1 curve is coming in Fusaka to enable cheaper verification of the passkeys curve, the most popular passkeys curves. That's the one that is coming most likely in November. More UX suggestions. We're looking back at the blind signing solutions that were proposed in the past. Here it is ERC 7730. Lots of other solutions around the dApps monitoring, the protocol upgrade alerts for the dApps, dashboards about the dApps, security of assets in the dApps. Lots of suggestions for the LLM scanners for smart contracts. I think we already see that LLMs are helping to deliver the very secure code. Those security checks by LLMs are one more tool that developers and security auditors have. The pay opcode to address reentrancy, most likely coming in Glamsterdam, to make sure that you can send assets without the risk of a malicious code execution. Then further smart contract security. So more real-time dashboards is what everyone is mentioning. L2bit is usually mentioned as a standard of how to create a good dashboard. Not necessarily that L2bit has to deliver all of these dashboards. This will be coming from independent providers. For the cloud suggestion, there are various solutions suggested for P2P, and the approaches, more professional approaches to building infra. On the consensus side, some kind of P2P-based slashing as well was suggested, quantum readiness, a lot of decentralization support for security for home stakers, more monitoring suggestions, again, for the LLM and real-time dashboards. And on the social layer, once again, a lot of coordination support from the foundation. The phase 2 actions, so WalletBeat support, we're providing grant for WalletBeat, and we'll work with them on helping to identify those metrics, security and privacy metrics, working with Verify Alliance on the blind signing standards, and also revisiting those proposals from the past around blind signing, human readability of what we're signing, and also avoiding code vulnerability by addressing the developer tooling. We're also hiring now the developer tooling coordinator for Ethereum Foundation, and also hiring project manager for this particular project for the $1 trillion security initiative. So please apply. Thank you so much.